All right, next up is 4.6, and we're going to be talking about solving equations using logarithms. So we've talked about solving exponential equations when you can get the bases the same. If you cannot get the bases the same, then that's going to be when you use logarithms. So here, if we have 100 times 1.35 to the n, the first thing I'm going to do is divide out this 100 from both sides so that all I have on this side is my base to my variable. And now if we remember back to last week when we were converting between exponentials and logs, this would become log with base 1.35 of 98.5 equals n. You need squeezies?
No.
Yes, you do.
No.
So then this we put in the calculator the exact same way we did that last problem on 4.5. So we would say, okay, before I do that, this is what they want when they say exact. So when they say exact, they want you to put this in. So this would be the log with base 1.35 of 98.5. Okay? And then the rounded answer would be what I get when I put it in the calculator. So log base 1.35 of 98.5, or, hang on, I did 1 and then a negative 35. There we go, much better. Or the log of 98.5 divided by the log of 1.35. Four decimal places, so 15.249.
I did.
That was fast. You must be hungry. You're in a great mood this morning, huh? You happy?
Happy.
No more?
Mom?
Still hungry? Will you drink some water for Mama?
Uh-huh.
Thank you. Okay. So this next question is going to look very similar. I'm going to isolate my thing with my exponent. So the first thing I'm going to do is subtract this 10. And then the next thing I'm going to do is divide this negative 40. .9. Okay. Now we're going to convert this into a log. This would be log with base e of 3.9 equals 9x plus 3. But we don't write log with base e. Log with base e is ln. Now we're going to subtract this 3. And then divide by the 9. So my exact answer here is the ln of 3.9 minus 3 over 9. Okay, that's my exact answer. And then my rounded answer would be the ln of 3.9 minus 3 and then divided by 9. 4 decimal places, so negative 0.1821. Okay. All right. On the other side. There's an exponent rule that I want to remind you of that says that you have a, if you have a times b to the x, you could make that a to the x times b to the x. So similarly, if you have a to the x times b to the x, you can make that a times b to the x. So I feel like we're taught this rule going this way a lot, but we're never really talk about the rule going this way. And this is totally an okay thing to do. So if I have 3 to the w times 2 to the 4w, well, I can take this w out the same way that I have the x here. So that would become 3 times 2 to the 4 to the w. This w comes out because if I were to distribute it back in, I would be back here. Now, what is 3 times 2 to the 4? Well, 2 to the 4 is 16 times 3 is 48. So we have 48 to the w equals 12. We'll turn that into a log. Log with base 48 of 12 equals w. And that is my exact answer. And then the log of 12 divided by the log of 48. 6419. Okay. All right. Now, if we have a log and you have your variable inside here, then you're going to want to turn this one into an exponential. So as an exponential, this would be 2 to the 4 equals 4t plus 6. But what is 2 to the 4? Well, that's 16. Subtract the 6. Divide by the 4. And that would reduce to 5 over 2. So my exact answer would be 5 over 2. And my rounded answer would be 2.5, even though that's not really rounded, but whatever. Okay. All right. So just like with the exponentials, if you have things happening outside of the log, you need to take care of those things first before you can turn it into an exponential. So I'm going to start here by adding this 10. Why did I write 110? That was strange. Then I'm going to divide this negative 2. And now I'm going to turn this into an exponential. So it would be 6 to the 5 equals 5y plus 4. 6 to the 5 is 7,776. Subtract the 4. And divide by the 5. My exact answer is going to be 7772 over 5. And then 772 divided by 5. Yeah. If you have more than one log, then use your log rules to combine them so that you only have one log. So here, in order to combine these, when you add, you multiply. So this would become the log base 2 of t times t plus 3. Which is the log base 2 of t squared plus 3t. And now this I'm going to turn into an exponential, so it would be 2 to the 6 equals t squared plus 3t. 2 to the 6 is, I knew that one. And this is a quadratic, so let's get everything together. So now, something I forgot to mention on the last 2 log equations, and that is a reminder that the domain of a logarithm is only positives. So you can only put a positive number in a log. It didn't affect us before because we weren't dealing with anything like incredibly weird. So here I got 2.5. Where am I? Can you see me? Here I got 2.5. If I plug 2.5 in right here, I'm going to get a positive number, so that's fine. If I plug, here we go. If I plug 1,500 in here, it's only going to become more positive, and so I'm going to be fine. You can only ever put positive numbers into logs. So at the end, you need to take your solutions, bless you, and plug them, bless you, and plug them back in and make sure that at no point would you be taking the log of a negative. Okay? Now, are there 2 numbers that multiply to a negative 64 and add to 3? 2 and 32, 4 and 16, no 5, no 6, no 7, 8 and 8, no. So when they don't factor, let's do the quadratic formula. So negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 64 over 2 times 1. What is 3 squared minus 4 times a negative 64? 265. I'm going to get decimal approximations because that's what it's asking for. So negative 3 plus the square root of 265 divided by 2. I wanted 4 decimal points. 4 decimal points. And then negative 3 minus the square root of 265. 265 divided by 2. Okay. So now we need to check these. If I take a 6.6394 and I plug it in here, it is positive, so that'll be okay. And then 6.6394 plus 3 would be 9.9394. That one's okay. But if I take a negative 9.6394 and I put it right here, I would be doing the log of a negative, which means that this answer is no, not good. And this is my only answer. We call this extraneous. That's the name for a value that we get when we solve that doesn't check. So, okay. And just like with rationals and radicals, since we have a domain exception with logarithms, you should be checking every problem. Okay. I'm not the biggest fan of this question, but let's do it. I'm going to move this over to the other side and take the 10 out. Now there's a GCF here. They both have a log base 3 of z, and they both have a 5. So this would be 5 times the log base 3 of z. Times the log base 3 of z minus 2. Because this was log base 3 of z squared. I took 1 out, so there's 1 left. I took this log base 3 of z out. I took out the 5. The negative 10 divided by the 5 I took out is negative 2. And now I'm going to set each one of these equal to 0. And I'm going to solve them separately. So if I divide both sides by 5 here, I would have log base 3 of z equals 0 still. And then 3 to the 0 equals z. And then anything to the 0 is 1. Over here, I'm going to move the 2. And then this would be 3 to the 2 equals z. So z equals 9. I don't like this problem. Check them both. 1 is okay, 1's okay, 9's okay, 9's okay. Okay, I'm going with it. I'm going to do something very similar for this one. If I pop this negative 2 out, I would have log base 4 of y squared minus 15 equals negative 2 times log base 4 of y. Now if I add this so that they're all on the same side, okay. I'm going to try something on this one that I probably should have done on the one above it just to make it like look a little easier. And I'm going to say, hey, for a quick second, instead of log base 4 of y, I'm going to write x. So everywhere I see a log base 4 of y, I'm going to change it to an x for right now. And then what I've got here, if I go all the way back to the beginning, is this becomes x squared minus 15 equals, I have to pop that negative 2 out, negative 2x. And if you were looking at it that way, then you can see how this becomes x squared plus 2x minus 15 equals 0. And this one factors x plus 5x minus 3. But we said that x is the log base 4 of y. So instead of x equals negative 5, what I actually have is the log base 4 of y equals negative 5. And then that would be 4 to the negative 5 equals y, which is going to be a decimal, really little decimal. A quick note, that e to the negative 4 means I take this decimal point and I move it back 4 spaces. So this would be 0.00097, but then the 7 would round the 9 up, and the 9 would round up to this. And so then instead of x equals 3, that's not a negative, that's a regular. I have log base 4 of y equals 3. So then 4 to the 3 equals y, and y equals 64. And if we check those, this would be positive, this would be positive for both of them since they're both positive numbers. Okay. Oof, I don't like those questions. But that is 4.6. We're almost done with chapter 4, only one more section to go.